So, good evening, all of you. Am I audible? Just let me know. Am I audible or not?
Good evening, ma'am.
Good evening. Good evening.
Yes, ma'am.
Okay. All right. So, let's begin. So, today we are going to see the continuation of the previous class. Okay. So, here today we are going to see a very important topic of this vibration will be the vibration of beam. Either it can be a longitudinal beam or the transverse section of the beam. Okay, but before that we will solve some more problems which are relevant to 2-degree problem, because last class we have not completed that much of problem. So we will see some of the different kinds of 2-degree of system problem. Okay, so first coming to, so this kind of problem already we have solved. Now please let me know that whether you have any questions relevant to this kind of problem. So first you have to analyze whenever there will be two masses. So that means that system is going to be the 2-degree of freedom system. Okay, so you have to judge that. Second is, whenever there is 2-degree of freedom, you have to find out the amplitude ratios. Okay, you need to find out the amplitude ratios. Now it can be of various types of this 2-degree system. You can also expect that there is a body of mass m1 and connected with only one single spring with another mass 2. Okay, you can also expect such kind of problems. Okay, so again, though it is only one spring and only having two masses, okay, there are only two masses, is two displacement x1 and x2. This will also undergo a 2-degree of freedom system. Okay, so similar way you need to find out, you know how to find out the frequency. How to find out frequency? We can write in two forms. One in f of n, 1 by 2 pi root over k by m, right? So k by m can also be written as g by del. Okay, that is 9.81 by deflection. It can also be written like this, or in terms of omega, we can write only root over km. That means f of n equals to omega n by 2 pi. Okay, so this is the system for this. All right, now we'll move to a different complex problem. What or how to solve such kind of problems? Okay, so here you have a main body. This main body is connected to one spring. Here we have a roller. Here another main body, another body too. Okay, having a roller connected to an spring. Let's consider this is K1, this is K2, this is M1, this is M2, where this K1 having 98000 Newton per meter, K2 value is 19600 Newton per meter, then M1 equals to 196 kg and M2 is 49 kg. Okay, now you need to find out the natural frequency for this particular body or particular system. These all are the fixed. Okay, these are the fixed region. Okay, these are the fixed region. All right, now first first and foremost thing what you have to do here is to find out the free body diagram. That is one equation you have to frame. So here we don't have any kind of damping system. So damping system will be 0. This is a basic formula. K of x will be 0, right? So what will be the equation for the first one? When we are fighting for the mass 1, what will be the formula? What will be the equation? Can I write m1 x1 double dot then plus k1 into, here we'll have two different displacement. Okay, this is x2, here we'll have x1. So what we can write? So what we can write?
X1 minus X2, ma'am.
Yes, when writing for k1, right, k1 is isolated. Okay, k1 is isolated with x1 alone, so we will write only x1. Okay, but while writing for k2, we'll be writing x1 minus x2, because k2 is a spring where it is sharing for both x2 and as well as x1. Now when we are finding for the mass 1, we will give preference for the x1 displacement minus of the second one, other one. All right, so we can rearrange this equation as m1 x double dot 1 plus, first we'll keep all the x1 then x2, so k1 plus k2 of x1 minus k2 x2 equal to 0. We'll equate this to 0. All right, now let's name this equation as 1. Next we will go for the mass of 2. So for mass 2, first simply we'll write m2 x double dot 2. Okay, now plus what this m2 is sharing with? M2 is sharing with only with k2, right? K2, what will I write here? What should be the displacement over here?
X2 minus X1, ma'am.
Very good. Here x2 minus x1 equate to 0. Now we'll simplify this one. M2 x double dot of 2, then minus k2 of x1, then plus k2 of x2 equate to 0. Okay. Now here you need to remember, we are going to transform this x double dot and x value. So x double dot represents, there is a derivation is there, that means small differentiation is there. X means a sine omega t. Now if x is a sine omega t, then x dot will become a omega cos omega t. Then if you further differentiate, okay, you will get differentiation of cos omega t will come minus a again omega square sine omega t. You will get this. Now what is your role is, now when you are finding for this double dot x double dot 1, right, the amplitude will become a1. Okay, when we'll find for x1, this will become like this. Now for x2, x2 will be a2 sine omega t, then x double dot 2 will become minus a2 omega square sine omega t. All right, so now what you need to do is you need to substitute. Now what I have said in the previous class, to avoid to save your time, you can simply ignore the sine omega t, because at the end of it, it will get cancelled off. Okay, so you can ignore it. All right, so if you ignore and if you substitute that in equation 1 and 2, what will you get is something like this, minus a1 omega square sin omega t will get cancelled off, plus k1 plus k2 a1 minus k2 of a2 equal to 0. Now if I want to make a ratio between a1 by a2 for the mass 1, I will get k2 by minus, okay, m1 is got missing, m1 omega square plus k1 plus k2, right? Now similarly, when you want to find for the second one, mass of for the second one, you will get minus m2 a2 omega square minus k2 a1 then plus k2 a2 equal to 0. If you want to make ratio between a1 by a2 for this body 2 or the system 2, so you will get minus m2 omega square plus k2 by k2. Please confirm me whether you're getting this system or not. Are you getting this system or not? Now after that, next step should be you need to equate a1 by a2 for the body 2 and a1 by a2 of body 1. You're just going to equate this two. Could you follow, all of you? Now after equating, what will you get if you equate into this system? So we'll get minus m1 omega square plus k1 plus k2 into minus m2 omega square plus k2 minus k2 square equal to 0. Now here in this given system, given question, they have given you the value of k1, k2, m1, m2. Okay, so you can simply substitute the value, right? You can simply substitute the value of the given m1, k1, k2, m2, k2, right? And you will get some kind of quadratic equation. You will get one kind of quadratic equation in terms of omega power 4 plus or minus whatever omega and some omega square and some value and equate to 0. Right? Solve that and tell me what is that equation you're getting. Solve that equation, substitute the values, because if you want to simplify this equation, you are going to lose your time. You don't have time, okay, during your exams. So you have to work very smartly. So what you can do is you can directly substitute the value in this particular equation itself, okay, and you can simplify in terms of this, some kind of quadratic form. Substitute that and tell me the answer. You can write down in the chat box or else. And once again, remember, always try to use the gate virtual calculator. Okay, that is also very equally important to use a gate virtual calculator. I will share the link in the chat box if you don't have again. Okay. Now, can you please provide me with your answer? Okay. Okay, what was the answer you're getting is 7.18 and 30.79. No, this is not the answer. This is not the answer. Okay, let's find out that whether this is the answer or not. Okay, so I think just ensure me that whether you're getting this value or not. That omega power 4 minus 1000 omega square plus 2 into 10 power 5 equate to 0. Are you getting this equation or not? Please write down. Are you getting this equation? You can either write down in the chat box. Yes, some are telling no, yes. 800 instead of 1000. Okay, just have a look. Okay, Mohit is telling that he's getting. Mohit, just let me know if you're getting this as 1000, then your answer should not be what you have got. Okay, just substitute very carefully, right? Substitute the formula, look into the plus and minus symbol. Okay, look into the plus and minus symbol very carefully. Here we have the square terms. Okay, so anyhow, when I was solving, I got this omega power 4 minus 1000 omega square plus 2 into 10 power 5. Okay, now what you have to use here, like Acharya's equation, a formula, minus b plus and minus root over b square minus 4ac by 2a. Now here the coefficient value is a value is 1, b is 1000 and c is 2 into 10 power 5. Okay. Now when you solve this, you get Like minus and minus, sorry, you have to include minus of 1000. Okay. So minus and minus will become plus 1000 plus and minus. Okay. So 1000 square minus 4 4 into 2 into 10 power 5, right, by 2, right? So please recalculate once again and tell me the answer what you're getting. Now this is the value, what the value which you will get is an omega square. Okay, here the value we'll get is omega square.
Hello, ma'am.
Yes, Mohit, tell
Ma'am,
me.
omega 1 equal to 16.62.
60.
16.62.
Yes. Omega 2 is 16.6, one is 16, and a point something, another is a
6
26.9.
point. Yes, ma'am.
Yes, absolutely. Prakash Balan, 24 you're getting, it is 2 into 10 power 5. It's coming around that. Okay. So you have to do this kind of calculation very carefully. Okay. Now omega 1 value here which I'm getting here is 26.9. This is in radian per second, and omega 2 value we are getting is 16.6 radian per second. Okay, these are the answers. Okay.
Hello, ma'am.
Yes, tell me.
I'm getting the same answer, ma'am. 26.89 omega 1 and 16.625.
All right.
Two.
Okay. Good. Now, shall we move to the different kind of problem? Like, let's not solve the full thing, but let's look into it how to solve that problem. Okay. Okay. Before this problem, let's solve it here itself. Okay. Now, so this figure is something different. It is fixed from the top. One spring is hanging. This is K1. One mass is there, is M1. Now from this mass 1, another spring of K2, and here another spring of another K2, both are same, and then finally one mass, that is M2. This both are having different displacement x1, and here we have x2 displacement. Okay, now how you're going to solve this kind of problem? How you're going to solve this kind of problem? Just tell me the overall idea about it, because previously we have seen such kind of figures. Okay, so how will you solve this? Here we have two masses, okay, two different masses attached with two springs. Now in this, how you're going to solve? Any idea?
Ma'am, both the values are same, ma'am. Like K2.
uh, K1 and K2 they have given same. If it is different, suppose it is different also. Sorry, if it different also, just consider it's different itself. How you're going to solve?
Ma'am, we can just try to reduce it, ma'am. Like the equivalent stiffness.
Very good. So what we are going to do here is, so whenever there is, so this system is going to be a parallel one. So we know what is mean by parallel. Parallel means we have to P parallel. We are going to use the plus addition. We are going to add equivalent of 2, 3. That is K2 plus K3. Right? So when we simplify this particular spring system, so we will get like this is K1. This is a mass. Whatever the mass were there, it will be remain as it is. So now the spring will become K equivalent 2, 3. And here another mass. Okay, M2. Right? So we will use this mechanism while solving this kind of problem. Got it? So we will not use any sort of gravity or something. Don't even think of it. Okay? So that is a different thing. Okay? So you have to make an equivalence or equivalent of this thing. Right? Okay. Now moving to next slide. Yes. Now what will be the equation for this 2 degree of freedom? Now here in this case, we have force but force is not in our syllabus. So we can ignore this force from this system. 2 degree of freedom system, force is not there. Force is there only for 1 degree of freedom, okay, as per the syllabus. Now suppose consider this is a complete system and here we have only the displacement for the mass 1 and mass 2. Okay. Now what will be the equations? When is the effect of gravity used? Here the gravity use only there when there are beams. Okay, if you see, if you're solving any kind of beam problem, this is not a beam problem. So in beam problem you're going to use the gravity, and if they have mentioned you that a self weight or the gravity, then only you need to consider. Otherwise you just need to ignore this gravity part. Okay. All right. So tell me the equation. Can you unmute? Anyone can unmute and tell me the equation?
Ma'am, am I audible?
Yes, yes, you are.
Yeah, yes, ma'am. M1, we have two displacements here, x1 and then x2.
So, okay.
M1 x1 double dot
Hmm.
plus the stiffness of the spring K1 into x1
Hmm.
plus C1 into x1 dot.
Hmm. Okay. Then, but mass.
And then mass 1 is also in connection with K2.
Hmm.
One second. Yes, ma'am. It's K2 into x1 minus x2, ma'am.
Hmm.
And then plus C2 into x1 dot minus x2 dot.
X1 dot minus x2 dot equate to 0.
0.
Okay. So this is the equation 1. Then what will be the equation 2? M2.
M2, should I say?
Yes, yes,
Okay,
absolutely.
ma'am. M2 into x2 double dot
Hmm.
plus K2 into, one second, ma'am. K2 into x2 minus x1, ma'am.
X2 minus x1.
x1.
Hmm.
That plus C2 into x2 dot. Like x2 dot minus x1 dot.
Hmm. Okay.
This is one set is over, ma'am, and it is in also connection with K3,
Hmm.
like plus K3 into
X.
x2, ma'am.
Yes, x2.
X2 and C3 into x2 dot
X2
plus.
equal to 0. We
Yes,
get
ma'am.
equation 2. Right? Now this form can also be written in a matrix form. Okay, sometimes in some of the question you can find they have given you in the matrix form. They might not provide you the system. Okay, so from the equation you need to find out the other parameters, right? Can you follow? So if the same equation are going to write in a form of matrix, so if I want to write in matrix, it should be something like this: m of x double dot should be okay plus k x, right, plus c x single dot equal to 0. Okay. Now if I want to write like this, so m1 0 0 m2, and here we'll have x1 double dot x2 double dot plus we have next k. So first we'll see, we need to rearrange the system, okay, because when we'll write for the k, we need to write for x1 and x2. So first we need to filter what are the x1 parameters we have. So we can write from here the above equation k1 plus k2, then we have minus k2, right? Can we write like this? Then for the next one we can write for minus k2, and then we have k2 plus k3. Okay, from this equation we can write plus c. C, we have to see again, whatever the C we write, we need to put as x1 dot and x2 dot and equate to 0 0. Okay, this will be the matrix form. Now see how to write C from here. So you need to write down C1 plus C2, then here we will be writing minus C2. Similarly for the second one, minus C2, here you're going to write C2 plus C3. Can you follow this? Can you follow this equation? Right? Okay, and all the remaining procedures going to be the same, right? Now what is the thing, they can also, this equation, the above equation what I have written over here, they can sometimes give you in this form, okay, in this matrix form. So from this matrix form also you can proceed further. Okay, so as usual process, what you're going to do after this, you're going to substitute the value of x value. What is x value? A1 sine, so if it is x1, a1 sine omega t. If it is x dot 1, it is going to be a1 omega cos omega t. If it is x1 of double dot, it is going to be minus a1 omega square sine omega t. Similarly for x2. Similarly for x dot 2. Double dot 2 also. So you need to substitute, and whatever the question they have asked in this given data, you just need to find out. Okay.
Can you give us 1 minute of time? Just copying it.
Yes, sure.
Finished copying, ma'am.
Okay. So similar kind of problems can be asked, right? So now we'll move to the next part, is the vibration of beams. That is today's main agenda. Okay. And this is the last topic of this vibration. Okay. So in this vibration of beams, what they do is, this vibration can either takes place longitudinally or in the transverse direction. Okay. So here we will see two cases. One is a longitudinal direction. Second one will be the transverse direction. Okay. Longitudinal or in the transverse. So here, so beam means there are a lot many supporting types of beam. Okay, either it can be of simply supported, cantilever, fixed, free, one side fixed, one side free, right? So basically here we will see two cases. One is a longitudinal
Am I audible, ma'am? Hello? Ma'am, your voice is not audible here. Mohit, am I audible? Irfan?
Yeah, you are audible.
Okay, fine. Ma'am is not audible for anyone, right?
Uh, Ma'am lost connection.
Okay, okay. Fine.
right now?
Yes, ma'am. You're
Okay.
You're audible, ma'am.
Okay. Is my slide visible to all of you?
Yes, ma'am.
Okay. So unable to erase it. All right. So is that clear that what are the things, or I should repeat once again? Should I repeat once again?
yes, ma'am.
Actually, only the topic was audible for us, ma'am. The remaining, the connection got lost after that.
Okay, fine. Okay. So here we will have two kind of vibration of beams. Okay, the first of all will be the longitudinal vibration of beam, and the second one will be the transverse. Okay, so transverse, when or they might not ask you a direct thing that about the transverse, the question from the transverse, when we will say, or when we talk about some kind of cross section, when the length is much longer as compared with the cross section thing, or I can say the breadth and the height. Okay, so when we talk something relevant to that, we will have to identify this is the thing from the transverse section, or they are going to discuss something about the transverse vibration of the beam. Okay, longitudinal, instead of longitudinal they can also say a word called like when any beam is subjected to axial force. Okay, or yes, in case of transverse they can use the word called transverse direction, or the load is along the transverse direction, something like that. Okay, so that means it is for the transverse vibration when they're using a word called axial force. Okay, so that time it means it is referred to an longitudinal one. Okay, and this transverse can also be when the breadth and height is much smaller, okay, than the length of the beam. So that condition also we can use that transverse vibration of the beam. Right. Now, in these two conditions, we will see some that what kind of beam category it falls on. Okay, so we will see three category of beam. One is a free beam, that is both the ends will be free. When both the ends of the beam will be free, we will see what kind of vibration and what is the frequency of vibration it will be. Second is free and fixed. Okay, free and fixed means when it is you can say cantilever beam. One end is fixed, another end is free. So cantilever beam, what kind of vibration it will undergo. Second is a fixed on both the ends. Okay, fixed on both the ends. So what it will be. Okay, so each and every this three different types of category will have the individual boundary condition. Okay, so we need to apply those boundary condition to a general solution of those beams. Okay, so as I've said, vibration of two category, one is a longitudinal and another is a transverse, each having its general solutions. Both are having its own individual general solution. So what you're going to do is, after the general solution, based on the category they have asked, each having their boundary conditions, we need to apply over here. We need to apply over here in the general solution, solve the equations, and we will get some final equation. That is our main requirement. Either you can remember the derivations, because here it is very important to know the final general solution for each and every beam condition. Okay, boundary condition for free and fixed, and both the ends are fixed, and how to apply and how to find out the constant terms, that is also equally important. Now second thing, so two types of questions can become. So first of all, this kind of question they mostly ask for 2 marks. So what they will do is, they will give you their general equation itself. They will give you the general equation itself. You no need to remember. See, I always prefer remember the general equation. We don't know how and what kind of questions they will appear. So most of the time they have given you the general solution. So A, B, C, D will be some constant terms will be there. So from that thing, you need to find out the constant terms, or they will ask you the either they can ask you the constant terms. Second type, they can ask you what will be the frequency, and third will be what will be the ratio of frequencies. Ratio of frequency means they will give you two category. If the category is free by frequency of free and fixed and free. So what will be the ratios? So either you can remember the final expression, or you need to, it is very, very important to know the derivation of this particular topic. Okay. So what we are going to do is first we will learn the general solution for each vibration of beam. Second, we will learn the boundary conditions, right? Third, we will go that how to apply those boundary condition in a general solution, right? And how to find out the constant term and followed with the frequency. Okay. I hope this is a very, very important topic, and this is, I think, not in your academics, I guess. Am I right? Have you studied this topic before?
No, ma'am.
Yes. So this is a very, very important topic, and sometimes they ask you for 2 3 marks from particularly from this topic alone. Okay. And here will be some kind of mathematical applications will also be indulged. Okay. Now first we will move for the types. Okay. So let me first category this page into two. So you can also split this if you are noting down this formula, split into two so you can compare the datas. Okay. So first I will go with a longitudinal vibration. Okay. So longitudinal vibration first I will go. Now first remember the basic equation. Okay. So they use for longitudinal vibration, they use a wave equation. Okay. They begins with, or the assumptions begins with a wave equation. So remember the wave equation. It is all a partial dou square u by dou t square, sorry, x square, t won't come here, x square, dou x square equals to 1 by a square. Okay, a is one constant. I will tell you what is a square, by into dou square u by dou t square. This is a wave equation. Okay, where a square defines root over of e by rho. Okay, root over of e by rho. Now, what is the E? E means Young's modulus of the beam. What is the material of the beam? And rho means density. Right? Now, when they resolve this, particularly for longitudinal vibration, okay? So, you need to remember the general equation, or you can say general solution. This is a general solution, particularly for longitudinal vibration. Okay. So equation something implies u of the function of x comma t, okay, displacement with some time equals to summation of leads from 1 to infinity. Okay, open the bracket, a sine p by a x plus b. This a b are some kind of constant, cos of p by a into x into c sine pt plus d cos pt. Okay, so where here p defines the frequency. Okay, frequency in radian per second. Okay, here p, now this convention might vary, right? So some of the textbook you can find they have given omega itself, so you can follow that also, right? So P refers to the frequency. This is the general equation. U into X into T. X is a function, U is a function of X and T. X means displacement, T is with respect to some time. And whereas A, B, C, D, these are the constant terms. Okay, after implementing the boundary conditions, you need to find out the this A, B, C, D constant. Okay, and second will be you need to find out what is the frequency, the p value, you need to find out that. Okay, so p can be find out very easily, you know this formula, right? You just need to substitute that, the whatever the value of p will get in terms of hertz. Okay, done. Now next we will move for boundary conditions. Okay, I will move for the boundary conditions. Now, as I've said, there are of three boundary conditions. Okay, the first one was when we have both the ends are free. Okay, so when both the ends are free, you can also expect to get a 1 mark question. So when both the ends get free, there will be no strain occur in the any beam. So strengths will be 0. Okay, or you can write zero strain, or you can write in when both the ends are free, we will have zero strain. So when there is zero strain at both the ends, consider this is a beam, length of the beam is L. Okay, you're starting from this point to this point. Okay, or you can starting from here. So we can write dou u by dou x when x tends to 0 will equate to 0. This is a first condition. Second condition for just a second. Okay, now when dou u by dou x, okay, will also be 0 when it reaches another end. So when x will become L. Okay, when x will become L, right? So these are the conditions will be implemented when both the ends are free. So from here, what are the things you got to know? So any beam when both the ends will be free, so there will be zero strain. So next is a boundary condition. Boundary condition is you have to that means when the zero strain means dou u by dou x will be 0. Okay, so from both the ends A as well as in the point B. Clear? Shall I move to the next? Please let me know.
Yes, no.
Okay. Now next is our when one end is fixed and another end is free. Here one end is fixed, another end is free. Okay, so here whichever n will be fixed accordingly, you have to choose. So we can say that, let's assume that the b means something like that. So you're starting from this end. Okay, so here it is x is 0, here x is L when you're reaching the other end. Okay, so in this condition, you can write, so u of 0 comma t, that means x becomes 0, t becomes as usual, will be also equal to 0. Okay, next thing will be when, so you know what is a free condition, then dou u by dou x of when x is equal to L, right, will be 0. That means at this point, if it is B point and this is A point, so at the B point, there will be no strain or zero strain. No or zero strain. Okay. And at the first condition, thing is there will be no displacement or displacement is 0 or the displacement is 0, right? So you can also expect this question in longitudinal vibration. So when both the ends are fixed and one end is free, which of the following options will be suitable for this condition? Okay. So you know this time it is a multiple option choice question. Okay, selection question. So you have to, on that situation, you need to select this both zero strain and displacement is 0 condition. Okay, you have to look into that question very carefully.
Excuse me, ma'am.
Yes, yes.
Ma'am, a small doubt. In multiple selective questions, will it be mentioned in the question paper that multiple selective question?
See, at the beginning in your gate exam, at the beginning, I
Hello?
request you, yes, please mute yourself.
Yes, ma'am, sure.
Yes. So what your question is like, whether how to know that whether it is a multiple selection question or just a single question, right? So at the when you are beginning of your exam, right, so they will give you certain instructions, so they will give you the numbering of the question, that from which module to which module this multiple selection, which module to which question to another which question will be your multiple selection question, and which question to which question will be your numerical type question. So they will give you at the very beginning. So you have to remember, when you see the question number, you have to note down that. So you have to know whether it is a multiple selection or a single selection. Okay, but I think in my guess, if they have not given you that options, that this is like they have not mentioned whether it is a new multiple selection or single selection, then you have to be cautious with your while answering. Okay, so that's what you have to do it. Okay, and second thing, for this multiple selection, as of they have said, it should be of 2 marks. Another thing, so if they're giving multiple, if the question belongs to 2 marks, that means it's sure that it is a multiple selection type question. Okay, did you get my point?
Yes, ma'am.
Okay, all right. So next category we'll go, third category, when both the ends are fixed. When both the ends are fixed. Okay, so here we will have certain categories. So when u of 0, that means initial condition, when x is 0, t remains same, the displacement will also be 0. When it reaches to that point, another point, that means here we'll have like something like this. This is A and B. That means both the A point and the B point there will be no displacement. That is a fact. Okay, there will be no displacement. Okay, these are the conditions for a longitudinal vibration. Okay, shall we proceed with one derivation for this longitudinal? Then we will move for the transverse.
We'll proceed.
Okay. So, okay. All right. Now let's consider the first condition itself. Okay. The remaining the procedure will be same. So now what I'm going to solve, I'm going to consider a longitudinal vibration of beam when this beam are subject to both the ends are free. Okay, both the ends are free. Now first, whenever I look into the question, right, first you need to remember the general solution. Now what was the general solution? It is of u of x comma t, right, summation of n equals to 1 into infinity. Then we have a, we had sine p by a into x plus b cos p by a into x. Then we have c sine pt plus d cos pt. This was the equation. Okay. Now, next step is to remember the boundary condition. Okay. So for the free conditions, or when both the ends are free, we know that there will be no strain will be acting on both the ends. So we have seen dou u by dou x when x is equal to 0, it used to be 0. So first condition. Second condition was dou u by dou x when x will be equal to L, also it will be 0. This is second condition. So that means we need to differentiate the first equation, partially differentiate the first equation with respect to x, right? So only we will get this, we will can substitute this. So what I'm going to do is partially differentiating with respect to x, right? So dou u by dou x when we do, so this is a constant term. So I can simply write it ahead plus d cos pt. Now I'm going to differentiate this two. So what will be the differentiation for the sine pax? Can you tell me? A is a constant. Then sine differentiation of sine p by ax. So can I write p by a cos p by ax? Can I write? Next, then we have b cos p by ax. So differentiation of cos will become minus. So minus b p by a sine p by ax. Can you follow this? Please, you can.
Yes, ma'am.
All right. Now this becomes equation 2. Now we are going to apply this boundary condition one by one. Now we will applying the boundary condition A in equation 2. Okay, so if we apply this boundary condition, A means when x tends to 0 and when du by dx also becomes 0. So then I can write here 0 equals to c sine pt plus d cos pt, right? Then here x is 0. Here we don't have any x term, so it will be as it is. So a p by a cos px cos of then cos 0 will become 1 and sine 0 will become 0. So we will become, it is 1 minus 0, right? So we will again can write 0 equals to c sine pt plus d cos p. Just a second, it is getting scribbled. So it equals to c sine pt plus d cos pt. Okay, then a into p by a, right? So this term, if I put it in the other side, will also become 0. So I say then a will becomes 0 for here. Can I write the main motto? First I said to find out the constant terms, right? Then I can say conclude, that means the value of a is 0. Can I? Shall I move to next?
Yes, ma'am.
Okay. Now what I'm going to do is I'm going to now move to that in second condition. Now I will apply the second boundary condition in the equation 2. Now this now a becomes 0, right? So first of all I will apply this this condition a equal to 0 into equation 2. Now if I write in the equation 2 a equal to 0, apply in equation 2, that means this value will get 0. This entire term will become 0. So we will have dou u by dou x equals to minus b p by a sine p by ax into c constant plus d constant, right? Let's consider this is equation 3. Now this boundary condition of b we are going to apply in equation 3. Can you follow? Right? This is a procedure. So once you get the constant, you need to apply back to the previous equation. Okay, previous equation, when you apply, you get this equation. Equation 3. That is C now applying boundary condition B in equation 3. Now before substituting, write down the equation. Okay, it was b p by a sine p by ax, then it was c sine pt plus d cos pt, right? Now what was the boundary condition b? That is dou u by dou x. When x tends to L, this strain will also be 0. This we are going to apply in the equation 3. So that means we get 0 equals to minus b p by a into sine pl by a, right? C sine pt plus d cos pt. Okay. Now again same thing, there's a constant term, so I can say minus b p by a sine pl by a equal to 0. Now this can be right sine pl by a equal to 0. Now what is another way we can write that sine 0? How we can write 0 in terms of sine? Mathematically you have solved something like that. Can you tell me how we can write the 0 in terms of sine?
Sine n pi, ma'am.
Very good. Sine n pi. So can I write here sine n pi? So where I can say n will becomes either 1, 2, 3, 4, etc. So on. Right? So any kind of integers it will be. So if I equate this and this, what will I get is PL by A equals to n pi. Now our main motto now, I'm getting some function of P. P is the frequency. Now I can rewrite the P as n pi A by L. Can I write like this? So what is the P value? P is n pi A by L. And what is A? A I have already discussed, that is E by rho. So I can again rewrite this P value as n pi by L root over E by rho. Now if I need to write in terms of frequency I can write 2 by pi. Okay, here we have n pi by L root over E by rho. So this pi will get cancelled off. So frequency can be write as n 2L by E by rho. This is a final thing. Now n can be, if they're asking first mode, then you need to apply the n value as 1. If they're asking for the second mode, you need to apply the n value as 2. Right? So whatever the number of modes they're asking, you need to substitute that value over there. Clear? So this is the frequency function. So if they're asking a direct question also, the frequency function for free, when both the ends are free, right? This will be the formula. This will be the formula. Right? So what you have done first you need to remember, first step you need to remember the general solution. This is a general solution, that is equation 1. Sorry, this is equation 1. Then you need to remember what is the boundary condition for that particular, this is a boundary condition for when both the ends are free. When both the ends are free. So this is a boundary condition. You have applied the boundary condition over here. Right? After applying the boundary condition, okay, so you have seen you need some kind of differentiation with respect to x. So first I found out the differentiation with respect to x. Then I have applied the first boundary condition. After applying the first boundary condition, I have obtained one of the constant factor, that is a becomes 0. I have applied to this previous equation a equal to 0. I got another new equation called equation 3. Now in this equation 3, I'm going to apply this boundary condition B. Okay. Now after applying this boundary condition, I just attained my frequency. Okay, frequency, that is this value I got. P is in terms of frequency. This is in terms of radian per unit, in terms of radian per second. A value I've just converted. A is root over E by rho, right? And which then I simplified in terms of hertz. This is in terms of hertz, and I got this value. Similarly, you can find when both the ends are fixed and free, right? So when you solve for the frequency for both the ends are fixed and free, you will get, so mostly they ask free both when both the ends are free and one end is fixed and free. Okay, these are the most commonly asked question. Okay, so n 4l root over e by rho. This will be the condition. Just you try to derive it, and you will get that this is the formula you get for this value. When condition is one end is fixed, another end is free. N by 4l root over e by rho. Okay. So sometimes they ask the ratios between these two, that is free, when both the ends are free, what will be the frequency? And they sometimes ask in second mode condition, what will be their ratios for free, free and fixed free. So you can simply find out that. That is the frequency for free, free and frequency for fixed and free. Can simply find out, that is if for the second mode whatever the no modes will be, you can write the n by 2l root over e by rho, here n by 4l root over e by rho. This n and n will get cancelled off, l, this things will get cancelled off, so you will get 2 finally. Now sometimes if they ask L becomes, twice the length of the previous one, then this length will become 2L very commonly, right? Can you follow this? Please let me know. Shall I move to the next?
Yes, ma'am.
Okay. So I hope you can do the fixed free condition. So same procedure will be followed. Okay.
For fixed, ma'am.
For fixed also you need to use the same way. Same way you can find out.
No, not that one. I just asked the formula.
For fixed, just a second. Mm, for just a second. Okay, for both, when both the ends are fixed, you get the same value as you get when both the ends are free. You get the same value. Okay, you get the same one as both the ends are free. There also you get the same thing as this one. Cp equals to n pi a by l. Yes, you get the same thing, n pi a by l. That is what you get for both the ends are fixed. Okay, for a longitudinal vibration. Yes. Okay. Now moving to transverse. Now transverse. So about the transverse, I already say that when the cross section of the beam will be much lesser as compared with the length. Okay, so here you need to remember which equations are used. Now sometimes this transverse vibration, they also call as an Euler-Bernoulli beam. Okay, Euler This is also known as a, this system is also known as a Euler-Bernoulli beam. Just a second. Okay. So here we'll have a different kind of equations. So this is also a wave equation in a different form. So here we'll use this formula, dou power 4 y by dou x power 4 plus rho a by e I into dou square y by dou t square equal to 0. Or it can also be written as dou power 4 y by dou x power 4. Just a second, okay. Dou power 4 y by dou x power 4 equals to minus rho a by ei dou square y by dou t square. Right? So noted? Have you noted this formula? So previously we have seen a different formula. Here we have, what is the order of this equation? What is the order of this equation? Can anybody say what is the order of this equation?
It's fourth, ma'am. Fourth, ma'am.
And what is the degree?
Degree is 1, ma'am.
Degree is 1. Now, here you need to remember the general solution. Here the general solution is little different. Okay. So here, since it is defined with in terms of y, so we will have the y is a function of x comma t. Okay. X comma t equals to a cosec c x, sorry,
Is that hyperbolic function, ma'am?
yes, it is hyperbolic function. Okay, plus into b sine h cx plus c cos cx plus d sine cx. Okay. Here everything is plus, and here we have four component. Okay, where c squared equals to p root over of rho a by ei. rho A by EI. So here you are seeing the C. The C defines that C square defines P root over rho A by EI. Right? Now we will move for the boundary conditions. So here we will have basically of two different types of boundary conditions. One is for the when both the ends are free. When both the ends are free. Okay. So here in this condition, okay, in this transverse, previously in longitudinal vibration, we have seen for each cases we had two boundary condition. One for this x is 0 and another when x becomes L. Okay, but here we will have four conditions. Okay, for each and every condition, that is when both the ends are free, we will have four boundary conditions for each thing. So for first one, what we'll have is when d square y by dx square, when x becomes 0, t will be as it is, will equals to 0. Okay. Second one, when d square y by d x square of L comma t equal to 0. Then third one will be d cube y by d x cube of 0 comma t will also be 0. And the fourth one will be when d cube y by d x cube L comma t equal to 0. Okay, and this the first two refers when we have 0 bending moment. Okay, so this is another concept when you're considering a transverse vibration of a beam, and when we consider when both the ends are free, on that cases there will be, that means there's a section, okay, when this is x equal to 0 and x equal to L whatever, right? So both the ends A and B, there will be no bending moment. Similarly, d cube y by dx cube refers that these two ends will have no shear force. This is another important concept. Okay, this will have no shear force. So first, please note down this formula.
Excuse me, ma'am.
Yes, please.
Ma'am, it's c square only, no, ma'am? Where c square equal to p into square root of rho a by ei.
Um,
This side, ma'am, left side.
uh,
See,
left
where c square equal to
c square equals to p root over rho a by ei. Rho for the density, a is the cross sectional area, e is the Young's modulus, I is the moment of inertia.
yeah, ma'am. That we got to like it's a c square only, no, ma'am.
C
C raised to
square.
2.
C square.
Okay, okay.
Hmm. So once you're done, just let me know. Okay. Shall we move to next?
Yes, ma'am.
Okay. So the next one will be one end is free and another end is fixed. Okay. So here also we will have four conditions. Okay. So first condition is, so you know, one end is fixed, another end is free. Okay. So in this, what we'll have, y 0 comma t will be equal to 0. That means here we'll be having 0 deflection at the fixed end. So here they're considering here x equal to 0, here x equal to L. At this point, fixed, wherever there is fixed, it will be having a 0 deflection. Okay. Now such kind of questions can also ask that if they give you one beam, right, and they can give you some of the points A, B, C, D point. Okay, some points they might give you, and they might ask you that where it will undergo a 0 deflection, whether it is a point B, C, D, and A, right? So such kind of question can also be expected. All right. So, so in this case, when one end is free, another end is fixed. So first condition is when there is no displacement at the x equal to 0 point. Now we will look into the slope. And that means if there is no deflection means what will happen to the slope? That means slope means dy by dx at the point x equal to 0 at some time, it will also be 0, no slope or 0 amount of slope. Then for this kind of condition, where we'll be having 0 bending and 0 shear force, we'll be having 0 bending and 0 shear force at the free end, right? So here the third condition we will have that dou square y by dou x square when x equal to L and t will be having 0, and the fourth condition is the shear force, that means d cube y by dx cube of L comma t will be also be 0, also be 0.
A small doubt here.
Yes, please.
Ma'am, I'm having a doubt in third condition, ma'am. You say that there is no deflection, free end actually.
No, this is free. Deflection means what? Deflection we define by y. So whether at this point when x equal to 0, whether any deflection will be there.
At the fixed end, it will not be there, ma'am. I agree with it.
At
But as at the free end, how the deflection is 0, ma'am?
where free, see there is free end, I have not written free end. If I write y equals to L comma t equal to 0, then only I will say that there is a deflection is 0. But I have not written that. I have not written. I have not written that.
Okay.
See,
Can you please explain the third one alone?
third one. Third one is d square y by d x square. It defines a bending moment. Okay. It defines, see here, wherever you see d square y by dx square defines the bending moment, and d cube y by dx cube defines the shear force. So that means what I said, at this point, at the free end point, there will be no bending moment. When the end is free, there will be no bending moment. Okay, that means when x becomes L, that see bracket L comma T, there is no bending moment at the free end. Similarly, there is no shear force at this free end, or I can say zero shear force. Did you
Yes.
get the one?
I
And
don't know.
zero.
There's a slight confusion actually. Sorry.
So here it is L. Okay, L is a function in place of x. It becomes L. Now, in this kind of transverse thing, they will either give you, mostly they will ask you to find out the what will be the what was that, your um, constant terms. Okay, what will be the constant terms? So first, similar way you have to do. Now you know this equation, y equation, that is y of x comma t is a function of this a cos h cx plus whatever it is. You need to partially you have to differentiate that twice. First you have, if it is a free, you have to differentiate it twice, then substitute this value x equal to 0, right, and equate to 0. You will get some value, some function you might get. Then second condition, you need to apply back to the previous equation. Same process will be followed, but very importantly, you have to remember this condition. You have to remember this condition. Okay? Would you follow? Am I audible to all of you?
Yes, ma'am.
Okay, okay. So,
So, ma'am,
yes, please.
um, could you check the chat box?
You're not audible.
Hello, ma'am.
You can write down chat box.
Please check
You can
the
write down.
chat box.
Okay, okay. There are some questions. Y is a function of x and t. Where is a t? T, actually there was a derivation and t got cancelled off. So in the function t didn't appear. Okay. So there is a derivation. Was there? Okay, Samarth? Samarth? In the notes I will share you the derivation. Okay, if you want to go through that, or else the book which I'm following is that very simple book you can download, or it is also there in my drive which I've shared, Mechanical Vibration by VP Singh. Very easy to understand, and they have given the detailed explanation over there. Okay, if you have that book, you can go through in that particular book, or if you don't have, I have shared in my drive, you can go through over there. Okay, dy by dx is your slope. Dy by dx is a slope. Okay, y is deflection, dy by dx is a slope, and d square by dx square is a bending moment, and d cube y by dx square is a shear force.
Ma'am, y is equal to displacement
Sorry?
and dy y equal to displacement and dy upon dx equal to deflection.
Can you repeat once again, Mohit?
Y is equal to displacement
Y equals to
and
displacement.
yes, ma'am.
See,
And dy upon dx equal to deflection theta.
whenever it is getting displaced, deflection is what? One kind of displacement only, we can say, right? Can't we say that? It is, see the magnitude of it. Here we are referring in terms of magnitude. Okay. So either if it terms as a displacement, here displacement we are referring in terms of x. Y is a function of x and t. Okay. Could you able to follow that?
Okay, ma'am.
So the y is a function of x and t, and here when we are referring in terms of deflection, slope, bending moment, and shear force, their degrees are just getting higher one after other. Okay. All right. So here it's a very small kind of derivation that we have to do it. So first let me write, let's move for the first condition. Okay. So here you need to find out what are the that constant terms. Here mostly they will ask you, or they will ask they will ask you to find out the constant terms. So based on the condition. Now first consider it is a free condition. Okay. And they have said it is a transverse beam. You have to look into the question that what kind of beam they have given, whether it is a transverse or it is a longitudinal one. So the conditions will vary. Now whenever they ask this kind of thing, remember the general equation, general solutions, that is y of x comma t equals to a cosec cx plus b sin cx plus, here we have c cos cx plus d sin cx. This is the formula. All are complete addition of all. Okay. Now in this free you need to know the boundary condition. You should know what is the boundary condition. Okay. Next. So for this, what is the boundary condition? Both the ends are free. So first of all, when both the ends are free, there will be no bending moment, no shear force. Okay, no bending moment, no shear force. So bending moment, I know it is d square y by dx square. Now when it is at the point x equal to 0, t it is going to be 0. Now d square y by dx square, when length, along the length, it is going to be 0. Now next comes shear force. Shear force means d cube y by d x cube. At the point x equal to 0, it's going to be 0. Now d cube y by dx cube at the point length into time going to be 0. Now first, what you're going to do is, this is the first equation, you need to differentiate the equation 1 twice. Differentiate the equation and tell me what is the equation you're getting. The value of d square y by dx square. You need to, here it is not partially differentiation, right? It is like ordinary differentiation here. So substitute solve, differentiate the equation with respect to x, and tell me what you're getting, d square y by dx square. I'm waiting for your answer. Where a, b, c, d are the constant terms, okay? And small c, you know what is small c? We know what is small c square is equal to 1 by p root over rho, just a second, rho a, sorry, not 1 by p rho a by ei.
And d square y upon dx square equal to a cos h cx plus b sine
A
cos hyperbolic function of cx plus b sine hyperbolic function of cx. Mem sine.
sorry. Sine cx
Minus
minus
c sin x, c cos cx
cos cx
minus d sin cx, all multiplied by c square.
by c square.
C square.
Right? So this is the thing.
Yes.
Now you are going to apply. Now this becomes equation number 2. Let's consider this equation 2. Now you're going to apply the first boundary condition in equation 2. Okay. Now what is that? That means d square y by dx square going to be 0, and x, wherever the x will be there, going to be 0. So you know cos 0 is 1 and sine 0 is 0. What about your remaining terms, cosec and the other terms? What happens for that? Similarly, for cosec, if it is 0, it will also become 1 for sine it. Okay, if it is 0, it will become 0. Okay. Now apply this condition over here. So I can say it is only a. This will become 0. This will become minus c. This will become 0 into c square. Now from here, can I write a equal to c? Can I write from here?
Yes, ma'am.
Now apply the next boundary condition. Now apply the next boundary condition. What was the next boundary condition? Is when d square y by dx square. Right? Now when we apply this a equal to c, in the we are going to apply that in the previous equation, isn't it? So further differentiate, we are going to apply when x equal to L. D square y by dx square equals to c square into, let's consider in terms of a. So a cos h cl plus b sin h cl minus a cos CL minus D sin CL, okay, equate to 0. Right? Now here we are unable to solve anything. So keep this equation as it is. Okay? Keep this equation as it is. We are unable to solve this thing. Right? Because we need some other terms to utilize this equation. So we will move to the next boundary condition to utilize it. Okay? We got this equation. We need to utilize this equation once again. Once we get some another parameters. So again, equation 2, we will differentiate with respect to x. So we need to get d cube y by dx cube. Now further we need to differentiate. So tell me what is the differentiation value you get.
Hello.
Tell me, I can hear you.
A sine hyperbolic function of Cx
A sine hyperbolic function of Cx
plus B cos hyperbolic
hyperbolic
function
function
of Cx
Cx plus C
plus C
sine,
sin Cx
okay,
minus D cos Cx
into
whole multiplied by C cube.
C cube. Right, very good.
Yeah.
Now again, now what you're going to do is, we know instead of C, it is also A. Can I write here A? Can I write here A in this place? Because already I found out this value. A equal to C. Right? Now I'm going to
Yes,
apply
ma'am.
this boundary condition C over here. Now I'm moving to next page. If I want to apply the boundary condition C in the previous equation, what will I get? That means d cube y by d x cube of, I think, what was the third one? 0 comma t equal to 0. So what I will get, 0 equals to c cube, and so sine this one will become 0. So again I will get b cosec and minus d. Right? So I will get b cosec cx and minus d cos cx. Sorry, it will become 1. So I will get like this. Those things will become 1. So again CQ will become 0. I will get b minus d equal to 0. So from here again I can conclude that b equals to d. Now finally, what was my motto? To find out the constant terms. So I got my A equal to C in case of both the ends are free, and when both the ends and B equals to D. Right? Now what you're going to do is, you're going to substitute back again and check that boundary condition for the second one. What happens? Could you able to solve this or not? This one. Now you get in function in terms of any two. Either you take A, B or C, D. Now try to convert that values in terms any one of the facts. Now tell me, what is the equation you're getting? Just check, are you getting something like this or not? Just check that whether you're getting this equation.
Yes, ma'am.
Right?
Yes, ma'am.
We're getting some kind of equations like this. Now here also you're unable to solve the sum of the facts, right? Now again move to condition D, the last condition. What was the last condition? 0 equals to dq by dx. Q L comma T, right? So you substitute the values and tell me what is the answer you're getting. And check whether you're getting something like this or not. So A sine HCl plus sine Cl plus B cos Cl minus cos Cl. Okay, you're getting the same. All right. Right now what the fact we can do now, both the side will be equate to 0, and if you are trying to equate to 0, right, now c will be moving to c square, will go to the other end, it will also become 0, this cq will also go to the other end, it will become 0. So finally, oh, just a second. So finally, you will get these two equations, right? Something in terms of cosec Cl minus cos Cl, right? So what you have to do is you need to simplify and find the value for that cosec Cl value. Okay? So by how you can do is this thing, you can simply multiply both the equations with this equation. If I want to find what is the relation between this, so I can multiply this equation with the b and this equation with a, right? And I can solve this and I will get what will be the value for this thing. This value and this value will get cancelled off. I will know what is the sine HCl value and all those things, right? Can you solve this? Right? So main aim is you will find out what will be the sine HCl ratios with the other component. And finally, you need to substitute back to this main equation. What is the main equation? This is a main equation here. So in case of transverse, you need to find out what is a constant term. And that constant term already you have found out, right? And next thing is you need to find out what is the relation between cosec cx with the other components, right? Clear? Is it clear? Just tell me, I got here, I solve for 1 and I got this value. The relation between them is cos HCl into cos Cl equals to 1. So I can say cos Cl equals to 1 by cos Cl. Just let me know when you solve this whether you get like that or not. How to solve it about A and B. A and B already solved, isn't it? We know what is the value. A equals to C we got here. C. From this previous thing, what you got? First we apply the first condition. When we applied, we got this thing. Right? A equals to C. Now, one of the values should be given. And they will ask you find out the unknown one or something like that. Okay, so you will know one of the unknown constant parameters, right? Then next was we use the third condition because second condition when we applied there was nothing to solve. So we apply the third condition. In the third condition, what we got? B equals to D, right? So when we resolve, we can also find the relation between what is the cosec values with the in terms of the hyperbolic function in terms of the normal function. Okay. A and B already found out. Samarth, is it understood? Please let me know. Ma'am, this thing written in grade. How to get this relation? Okay, okay. If you are unable to get, let me tell you. Oops, sorry. So here both the ends you have this c square and c cube, right? So basically you will get from the D and B and D, you will get two equations. One is A cos H CL minus cos CL, right? Plus B sin HCl minus sin CL equal to 0. This is one equation you will get. Now next equation from this, you will get A sin HCl plus sin CL, right? Plus B cos HCl minus cos CL equal to 0. Now I'm going to simplify these two equations. How I can simplify? Now let me multiply this above equation with B and this equation with A. Now if I multiply the above equation with B and this equation with A, what will I get? Let me change the color. So I will get A into B, this B square. Here I will get A square and here I will get A, right? Now I'm going to simplify this equation. Simplify that equation. Here we have plus, minus, minus, right? Now can I cancel off this equation and this equation? Can I write B square sine CL minus sine CL, okay, minus A square of sine H CL plus sine CL equal to 0. Now if you simplify that equations, just a second. Let me check once again. Okay. So how you're going to simplify this? So let me work over here. So cos HCl minus cos Cl is a common term. So can I write this minus B sine Cl, sorry, sine H Cl minus sine Cl. B by A. Next equation was A sine H Cl plus sine Cl plus B cos Cl plus, sorry, minus cos Cl equal to 0. Now this here I'm going to substitute this value. If I substitute this value, A square of sine HCl minus sine Cl cos HCl minus cos Cl, and here there will be A square sine HCl plus sine Cl. Okay. Yes, right. A by B equals to CL by cos HCl minus cos CL. Okay, this is for the B condition. D condition is A by B. For D condition, we will get that minus sign will be there. Okay, and here we will have this condition minus of cos HCl minus cos CL, and here we'll have sin HCl plus sin CL. Now equating these two, we will get that minus sin HCl minus sin CL. This minus and minus will get cancelled off. Can we cancel? The sin HCl plus sin CL equals to minus cos HCl minus cos CL into cos HCl. Is this equation correct? Please let me know. I think there is a mistake within some plus and minus.
It's coming in form of A plus B into A minus B.
No, I think there is, is this equation correct?
Just a second.
Just check once and tell me. I think there is some.
Sorry, ma'am, like more than half the way, I just left a few steps, ma'am. I'm not able to check it properly.
Okay. So we'll have cos HCl minus. We'll proceed and let's see. And here we'll have, so this is minus. So we can write sin H square Cl minus sin square Cl. Can we write like that? Okay. So finally we can write minus sin H square Cl sin square Cl minus become plus of cos HCl minus cos Cl whole square equal to 0. Okay, let's simplify this. Now if you simplify this cos H square Cl, then you will get plus cos square Cl minus 2 cos H Cl into cos Cl, right? Then here we'll get minus sin H square Cl plus sin square Cl equal to 0. So here we have minus sin square, here we have plus. So cos H square Cl minus sin H square Cl, whatever, equals to 1. Here we have cos square Cl plus sin square Cl will be equals to 1, right? So I can 1, 1, so 1 plus 1, 2 minus 2, this is the remaining term, cos HCl into cos Cl equal to 0, right? So you put this other way, Yes, cos HCl into cos Cl, it becomes 1. So finally you get cos HCl equals to 1 by cos Cl, which is not a sec Cl. Is it okay?